All right, so today's lesson is called triangles. We have been talking about angles for quite some time. Now we're switching over into triangles. We're still working with angles because triangles are made up of angles, but we'll be talking about some features specifically that deal with triangles. So we're going to talk about, and these first two objectives should be a review from earlier grades, how you classify or name triangles by the angles, and then how you classify or name triangles by the sides. How you classify or name triangles by the sides. And then also how to use the triangle angle sum theorem to find a missing angle in a triangle. And this is our standard from 7th grade that you need to be able to identify or describe the properties of all types of triangles based on angle and side measures. Okay, so the first is classifying triangles by angles. I'm going to see how much of this you know. Anybody know what we would call this triangle based on its angles? Irene?
Acute triangle.
An acute triangle. Good. In an acute triangle, all three of the interior angles are acute. What does acute mean in terms of angles? Adria?
They're smaller than 90 degrees.
They're smaller than 90. So all of the angles are smaller than 90 degrees. Can anyone tell me what kind of triangle this one is? Katie? A right triangle. And in a right triangle, exactly one interior angle measures 90 degrees. And we have that here. We're used to seeing this little square symbol as a way to tell us that an angle is 90 degrees or a right angle. Okay, last kind of triangle. Grace?
Isosceles.
No? Adria?
Obtuse.
Obtuse. This triangle is an obtuse triangle, and exactly one interior angle is obtuse. What does it mean for an angle to be obtuse? Anyone know what it means for an angle to be obtuse? Sky?
120. Like an angle of 120.
It doesn't have to be 120. Eve?
Has an angle greater than 90 degrees.
Good. An angle greater than 90 degrees is an obtuse angle. Okay, now we go into classifying triangles by sides, naming them based on their side lengths. So the first triangle, all of the sides have different lengths, and you can see these are called tick marks. This side has 1, this side has 2, this side has 3. That just means that they're all different from one another. Does anyone know what that kind of triangle is called when all the sides are different? Starts with S. Jake?
Well, after you said S, are you going to say an unequal or
Not quite. Ross? Scalene. It's called a scalene triangle. Okay, this triangle, the two of the tick marks are the same. They both have 1. That is showing you that those two sides are the same length. What kind of triangle has 2 sides that are the same length? Carly? Isosceles. Okay, and the last type of triangle, all 3 sides are the same length. Irene?
Equilateral.
Equilateral. There's another one, back on the angles page, if all of the angles were exactly the same, we call that an equiangular triangle. So it's possible to name an equilateral triangle by both its sides and its angles. If you have an equilateral triangle, all 3 sides are equal. If all 3 sides are equal, all 3 angles are also equal. So an equilateral triangle is also equiangular. Okay, this practice, we are going to classify each triangle by its angles and its sides. So each triangle will have 2 names. It will have a name based on its sides, and it will have a name based on its angles. Zoe, give the first one a try. You can look back at the notes. I don't expect you to have all these memorized right away. It's acute. And what else is it?
That Equilateral.
Equilateral, so it's acute and equilateral. Okay, number 2. Here, Eli, give number 2 a try.
It is a scaling obtuse.
Good, scaling obtuse. Okay, number 3. Riley. Acute. Isosceles, good. Acute isosceles. And the last triangle, McKenna.
Scaling and right.
Good. Scalene, right. And it doesn't specifically tell us that it's right, and it really should, because we have to be careful that we don't assume that angles are right angles, but in this case, it is supposed to represent a scaling right triangle. Okay, here is the triangle angle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. So when we take the 3 angles in a triangle, this says the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. If we add these 3 together, they equal 180. So the interesting thing you can do, and I forgot to get my triangle out, but if you have a triangle and you cut the tips off of the triangle and then you line up those tips together, they form a straight line because it's equal to 180 degrees. I'll have to pull that out for second period. I'll show you that. So the angles in a triangle always add up to 180 degrees. So if we look at example 1, we know that one of the angles is 26 degrees, another angle is 35 degrees, and we don't know this angle. So if I were going to write an equation, I would say that x plus 26 plus 35 equals 180. Combining like terms gives me x plus 61 equals 180. Subtracting 61 from both sides gives me x equals 119 degrees. Volunteer to do number 2. Irene.
So x plus 35 plus 65 equals 180.
Okay?
Plus 100 equals 180.
Oh, x plus 100. Okay.
Yeah.
Okay?
And then it would be x equals 80
Good.
degrees.
X equals 80 degrees. Jimmy, try number 3. Let's finish the whole equation before we combine like terms. So 58 plus 90 plus what's the third angle? Jimmy, look at the other examples. What did we add for the third angle? Okay, so plus x equals what? Good. Okay, now when we add these together, we get, okay, so 148 plus x equals 180, and x equals, good, 32 degrees. Okay, any questions about those? Those are the basic, easy type. I think on Get More Math, that's the only type they give. They don't have any more complicated examples with triangles. We're going to look at some, though, because I'm going to give you a paper worksheet that has some of these. We only have about 2 or 3 minutes left, so let's see if we can get through at least 1 or 2 of these, and then you'll be good. All right, so number 1, if we were to write an equation, who would like to volunteer to tell me what that would be? Grace.
X plus 74 plus 55 plus 54 equals 180.
Good. Okay, so then we combine like terms. I'm just going to do this quickly. We get x plus 183 equals 180, and we get x equals -3. And it's okay to get a negative answer for x if x is not an angle. If the whole angle were x, a negative answer would be a problem. But -3 is okay for x because what would the whole angle be if x is -3? 71. The whole angle would be 71. Okay, who would like to set up? Let's do number 4. Anyone want to set up number 4? Jake.
X plus 37 plus x plus 67 plus 90 equals 180.
Okay, good. Now on this one we have 2 x's, so when we combine like terms, these x's are both on the same side, so we're just going to add them together. 1x plus 1x is 2x plus 194 equals 180. Subtracting 194, we get 2x, I have to write it way over here, equals -14, and x equals -7. And we could substitute that in for either of these angles to find out what they are. So one of the angles would be 30, the other angle would be 60. We are going to end our lesson there.
This